Good morning, this is your Stat Sensei, Mr. Sensei, and this is Death Packet Problems 31 through 44 proportions. It also deals with errors, and that's where we're going to right now. If all other factors are held constant, which of the following results in an increase in the probability of a type 2 error? As a reminder, type 2 error is a fail to reject. All right. Type 2 is fail to reject. And remember, you're failing to reject a false null. So the assumption is the null is false and you fail to reject it. So let's look at these individually. The true parameter is farther from the value of the null hypothesis. Well, if we had a t statistics, t equals x bar minus mu s divided by the square root of n, the farther the true value is from farther the true mean is from the claim, means I'm going to end up with a larger magnitude, making it easier to reject. So the farther they are, the easier it is to reject, and we need a fail to reject. All right, making it easier to reject a true null means that we decrease the type 1 error. We actually decrease the type 2 error. The sample size is increased. As I increase the sample size, then this total value under here gets smaller. And as this part that I'm dividing by gets smaller, it means I'm going to end up with a larger t statistic. The larger the t statistic, the easier it is to reject. Again, we're not looking at for making it easy to reject. We're looking at to fail to reject. So that won't happen. The significance level is decreased. Okay. So alpha and beta, I can't calculate beta from alpha, but they do move in opposite directions. So if the significance level goes down, then beta actually does go up. All right. And beta is the measure of type 2 error. The next one, the standard error is decreased. If I decrease this, that means I'm dividing by a smaller number. Dividing by a smaller number increases t statistic, which means I'm farther into the tail, which means I'm more likely to reject. Again, that helps with rejecting. All right. Which of the following is defined by the significance level of a hypothesis test? All right. Significance level, that's alpha. Alpha is the measure of a type 2 error. So in this case, I'm saying it is the probability of a type 1 error. Our best answer choice is D. 33. At a manufacturing company, the percent of defective items produced on the assembly line is 2%. The company is testing a new assembly line designed to reduce the percent of defective parts. The null and alternative hypotheses are described as below. Is at least 2%, is less than 2%. We probably would have said equals 2%, equals 0.02, and this is going to be less than 0.02, but pretty much the same thing. Which of the following describes a type 2 error? All right, so type 2 error. Type 2 means type 2 is a fail to. Well, to fail to, that means I believe this, means what I don't have enough evidence. So the test does not provide convincing evidence. So any that says convincing does provide, they're wrong. So that gets rid of D and E. We don't have enough to reject it. We're not going to reject it. All right. So the test does not provide convincing evidence that the percent is less than 2%, but the actual is 3%. Well, that doesn't make sense. And the reason it doesn't make sense is like, well, yeah, that's not an error. It doesn't say that it's less than 2% because it actually is 3%, and 3% is not less than 2%. So no error was committed. The test did not provide convincing evidence that the percent is less than 2%, but the actual percent is 2%. Well, equaling 2%, not less than 2%. That's not an error. The test does not provide convincing evidence that the percent is less than 2, but actually it is. Oh my gosh, it really is less than 2, and we didn't reject because we didn't have enough evidence. That's an error because we failed to reject when it was 1%, and we thought we didn't have evidence that it was less than 2. So number 34. If all other factors are held constant, which of the following results in a decrease in the probability of a type 2 error? Decreasing type 2 error means I need to be able to reject more easily. The true parameter is closer to the null hypothesis. If they're close together, it's hard. And they want to decrease the probability. If they're close together, that makes it hard to reject. Consider this. If I had a t equals x bar minus mu s divided by square root of n, the closer these values are, the smaller my t statistic, the harder to reject. Or if I'd been working with a proportion, and I go z equals p hat minus p over 1 minus p over n. The closer these values are together, the smaller my z value is. The smaller the z value, the less likely I am to be rejecting, because we need to be out in the tails to reject. So A is wrong. The sample size is decreased. Okay, if I decrease my sample size, if I go from, I don't know, 100 to 10, that means this area, this thing right here, and I'm dividing by this whole thing. If I'm dividing by that and I decrease this, that means I'm decreasing by a smaller value. That means I'm dividing by a smaller value. If I'm dividing by a smaller value, I end up with a smaller t statistic. So that doesn't help. The significance level is increased. All right. So, or decreased. So if I take alpha and alpha and I decrease it, then beta, increases. All right. If alpha increases, then beta increases, and we're looking to decrease it. The standard error is decreased. If I decrease the standard error, that makes this smaller. All right. And if this is smaller, that means I'm dividing by a smaller number. If I'm dividing by a smaller number, that means my t statistic is getting bigger. If my t statistics get bigger, it's easier to reject. The easier it is to reject, the less likely I am to fail to reject. So the answer choice to 34 is D. So 35. A large company offered gym memberships to its employees as part of a program to keep employees healthy. A random sample of employee with gym memberships and random sample of employees without gym memberships were taken. So we have two samples. A 90% confidence interval for the difference in population proportions was found. Employees believe there is no difference in absenteeism between those with gym membership and those without gym membership. Does the confidence interval provide that this belief is plausible? Well, looks like it might be plausible to me. And the reason it's plausible to me is because no difference means zero is contained. And I look at this and I go, hey, if zero is contained, then it's plausible. So yes, the length of the interval, yes, the value of zero is contained in the interval, which indicates no difference. All right. And we could have eliminated those because we knew 0 was contained. In a population of bats living in a certain region, 30% have a wingspan greater than 10 inches. All right, so we have 30%. So P equals 0.30. In a random sample of 80 bats living outside of the region, 20 had a wingspan greater than 10 inches. So we took a sample and we got a P hat equal to 20 over 80, which is 0.25. All right. Consider a one sample z-test. Which of the following is the correct test statistic? Well, z equals p hat minus p naught over p naught times 1 minus p naught over n. Well, that means we have 0.25 minus 0.30. So let's make sure that we're in this order. Well, that gets rid of this one and this one and this one. The next thing, in our denominator, we make sure that we're working with P naught. So this is 0.30 times 1 minus 0.30, and 1 minus that is 0.7 over the sample size of 80. That means our answer choice to 36 is E. 37. I'm going to let you know that 37 is an error. I'm still going to talk about it though, because I know what it should have said. First off, this right here should have been a greater than. 90% confidence interval for the difference of proportions in P1 minus P2, and it should have been P1 minus P2, was calculated to be 0.247 to 0.325. And which of the following conclusions is supported by the interval? Well, there's evidence to conclude that P1 is greater than P2. Yes, there is. And the reason there is because both are positive. Because remember, you're subtracting one minus the other. So because both are positive, it's not because 325 is greater than 0.247. That's not why. It's because all values in the interval are positive. That's why it's plausible. Okay. But this was a typo, so I think it's listed as a skip, unless yours is done differently. 38. Machines in a bottling plant are set to fill bottles to 12 ounces. The quality control officer at the plant methodically tests the machines to be sure that the bottles are filled to an appropriate amount. The null hypothesis of the test is that the mean is at least 12 ounces. The alternative is that it's less. So basically, we have a hoe mean equals 12 ounces. The alternative is mean is less than 12. Now, you could argue that that should have been mean is greater than or equal to 12, but regardless, you're going to get the same results. We're wanting to know this. Which of the following describes a type 1 error that could result in the test? Type 1, I rejected this, and this was true, and I believed this. So I believe it's less than 12 when it really is 12 or more. And to do that, I had to have enough evidence. So the test provides convincing evidence. This says does not, does not, does not. The test provides convincing evidence that the mean is less than 12 ounces, but the actual mean is at least 12 ounces. Oh, that's at least 12. That's our answer. When we look at E, the test provides convincing evidence the mean is less than 12 ounces and the actual mean is 11 ounces. Well, guess what? 11 is less than 12. You should be rejecting. That's not an error. All right. The error is rejecting when it wasn't. 39. Approximately 38% of the people living in region W have blood type O. A random sample of 100 people from region X revealed that 35% in the same sample had blood type O. Consider a hypothesis test to investigate whether the percent of people in region X with O is different from region W. Which of the following is appropriate null hypothesis for the investigation. First off, we need to be looking at different. And anything with p hat is wrong. And which of the following is the appropriate null? So to be null, it has to be an equal. So that gets rid of that. So we're looking at this. 38% have it in O, have it in W. That did not come from a sample. That was from, oops, that 38 did not come from a sample. So region W is 38%. A random sample of X. So P hat came from X and X was the 0.35. All right. So this came from the sample, that's X. This came from W, that's 38. So this is our hypothesis claim. 39 should be C. Oh, excuse me. I said it's supposed to be 38 and I circled 35. My bad. 39 should be E. Didn't circle what I said I was circling. Based on the findings from a recent study on women's health, researchers created a 90% confidence interval, 42 to 48, to estimate the percent of all women who do not find time to focus on their own health. So 42 to 48% of women do not find time. So that means at least 42%, but no more than 48%. So less than well, we'll come back to that. Let's look at our answer choices. Which of the claims is not supported? Less than half of all, not supported. Less than half of all women do not find time to focus on their health. Yeah, 48% is less than half, so less than half do not focus. That looks like a true statement. We're looking for not true. More than 40% of all women do not find time. Well, 42 is more than 40. Both ends are, so that's true. Approximately 45%. Well, if I add these two together, I actually find my p hat. 0.42 plus 0.48 divided by 2 equals 0.90 is 2. That's my best estimate, actually. That actually is p hat. And so approximately 45%. So that looks like that's true. More than 45% of women do not find time to focus on their health. This is tricky. Really, I'm going to make a number line here with whole numbers, and I know we could have decimal percentages, but let's just say we had 0.42, 0.43, 0.44, 0.45, 0.46, 0.47, and 0.48. It says more than 45%. Well, that means this group. Well, it didn't say that. It could have been 44%. It could be that, but this is also possible. So this is the one that's false because it has to be true for all values mentioned, and that is not. All right. I appreciate you watching and hope to see you on the next one. Thank you.